Hey guys, Mr. Milton here. Today we're going to talk about multiplying and dividing by a monomial. At the end of this lesson, you should be able to multiply a polynomial by a monomial, and you should be able to find the GCF of a polynomial and divide or factor it out of a polynomial. Okay, so first we're going to review, make sure we understand some of the basic rules that we're going to apply during this lesson today. Okay, and first things first, we have simplify 5x cubed plus 2x cubed. Okay, so we need to answer ourselves what operation is being used here. Addition is being used. Okay, we can tell because of the plus sign. Okay, and do the exponents change with this operation? Remember, the answer is no. When we add and subtract, it doesn't change what it is. It just makes more or less of them. So 5x squared plus 2x squared is 7, or x cubed is 7x cubed, 5 plus 2. Okay, and then we have simplify a to the 4th times a squared. You know what operation is being used here is multiplication. Multiplication, and remember that in this case, this is our last chapter, the exponents do change. Okay, remember when we multiply bases with this exponents with the same base, then we add those exponents. 4 plus 2 is 6. Okay, when adding or combining terms, the exponent does not change, but in multiplication or distributing of terms, it does. Okay, so let's look at this next section with some examples attached. Good, okay. So down here we have 3x squared plus 3 times quantity x squared plus 4x minus 5. We're going to multiply each monomial into a polynomial. And so what we're going to do is we're going to be distributing the number on the outside to all the terms inside. Distribute, distribute, distribute. Okay, and so 3 times x squared is 3x squared. 3 times 4x is 12x. 3 times negative 5, negative 15. Okay, notice there are no like terms here, so we don't have to add anything, we just have to multiply. Okay, we'll go through the next one. We have 4b times 5b squared, so we do 4 times 5, which is 20, and then b times b squared is b to the 3rd. Remember, this b has an exponent 1. Okay, we'll do the same thing, distribute, distribute. Okay, and so here we'll get minus 4b squared. Okay, then finally 4b times 1, which is just plus 4b. Okay, so there we go there. I am going to leave this one, number 3, to you, so try that out. Make sure you give me your answer for your notes. I'll check those tomorrow. Okay, then let's do 4 together. 4 is a little bit different. It has a couple variables there. Doesn't really change our rule, but I know it can look a little bit more intimidating. So again, 2ab cubed. We're going to distribute that to the terms inside. So 2 times 4 is 8. A times a squared is a to the 3rd. B cubed, b is b to the 4th. Okay, and then I'll distribute this to the 2nd here. So times a negative, I know this is going to be a negative sign. So 2 times 5 is 10. A times, well, there's no a over there, so just it's going to be a. And then b cubed times b to the 4th is b to the 7th. Okay, so notice how those exponent rules carried over. Again, remember to do number 3 for me. Okay, so that's multiplying. Now we're going to talk a little bit about factoring, just a little bit. And so as we do that, I want to first list the factors of 36. Remember, a factor is a number that evenly goes into the number when we multiply or divide. Okay, so I know that I usually do this by saying, starting with the lowest 1, and then going up to the numbers using its matching thing. So 1 times 36. I know those are factors. Okay, 2 times 18. 3 times 12. 4 times 9. 5 doesn't go into 36 evenly. 6 times 6. Okay, and again, now that means I've gone through all the numbers. Once I reach the lowest number that or once I reach a number that I already have written down, I know I don't have to do it anymore. Okay, and so here are the factors of 36. Just all the numbers that multiply into 36 evenly. Okay, now the greatest common factor is the biggest number that goes into both numbers. Okay, so now we have the task of finding the greatest common factor between the numbers 12 and 18. Okay, the long way to do this, and the better you are with number of facts, the easier this will be. But the long way to do this is to list out those factors. Okay, and I usually like to find the prime factorization. So that's what I'll do. I usually think, okay, what multiplies to give me 12? So, I don't know, 2 times 2, that's 4 times 3. Okay, what multiplies to give me 18? 2 times 2, which is 4. Well, actually, let's 2 times 3 times 3. Okay, and so they both have 2's. They both have 3's. So the biggest number that goes into both of them, 2 times 3, is 6. So the greatest common factor is 6. Okay, we could do the same thing this way, kind of listing those out as like 1 and 12, 2 and 6, 3 and 4, and do the same thing as 1 and 18, 2 and 9, 3 and 6. Okay, and we say, well, what's the biggest number that fits into both of them? 6 would be the biggest number that fits into both of them. Okay, so a couple ways that you can find the greatest common factor. Okay, the more you do it, though, the easier it is going to be for you to identify what the greatest common factor is. I don't expect that kind of work to find that. Okay, I'd hope that at some point you have kind of acquire some number sense to just be able to go with that. Okay. Now we're going to do the same thing here with some variables and exponents added into it. We're going to find the GCF between 4x cubed, 12x squared, and 8x. Okay, and again, I like the factor method just because to me it allows us to write less, I think. Okay. Now, as I look through this, I have 4, 12, and 8. I'm going to just look at the numbers. What's the biggest number that goes into 4, 12, and 8? Well, I know 4 goes into 8, 4 goes into 12 as well, and 4 has to be the biggest number that goes into 4. So I know my GCF is going to be 4. Okay? Now look at x cubed, x squared, and x. What's the biggest number that goes into all of those? Well, x goes into all of them, and it's big there. So my GCF would be 4x. The biggest number that goes into evenly all these numbers. Okay? Alright, and so this problem isn't any different than this problem. Okay, notice it's asking for the GCF. This is asking for the GCF. Even though this is an addition, it's subtraction, it's a polynomial, it's not any different. We're going to go through the same process. So I go through 4, 10, 14. What's the biggest number that goes into all of these? Well, they're all even, so 2 goes into all of them. Okay, 2 divided 2. 2 is the biggest number. And then I'm going to look at the exponents. I'm going to say, okay, x to the 5th, x to the 4th, x to the 3rd. They all have at least 3 x's in it, so that's the greatest common factor, x cubed. Really don't have to worry about positives and negatives in this case. Okay, as I look at number 2, I have 3t squared minus 18. Okay, between 3 and 18, I know 3 goes into 18, so that has to be part of the GCF. I have t squared here, but I don't have any variables here, so I won't have it in my GCF. My GCF here is just going to be 3. And then number 3, there's 3 terms. Let's see, we got 4x cubed, 6x squared. So 4, that's an even number. That's 2 and 2. 6 is 2 and 3. This is 3. So you notice, hopefully, that, well, these two have 2's and these two have 3's, but there's nothing that's shared by all 3. So our GCF as far as numbers go is 1. It's the biggest number that goes into everything. Okay? Then when we look at our variables, this has x cubed, this is x squared, this doesn't have anything. So there's no variable in our GCF. Our GCF between all these terms is just 1. Okay? And that's possible. Okay? Now, finding the GCF is only the first step in factoring polynomials. Okay, the second step is dividing each term by the GCF. Okay, and so now that's what we'll practice in this next section. We'll do 4 of these, and I'll leave 2 of them for you to handle and bring in on your own. Okay, so the ones that I'm going to leave for you to handle and do on your own are number 4 and number 5. Okay? Alright. Let me have you do number 6. Okay, 4 and 6. I'll do 5. Okay, so let's look at number 1. As I try to straighten up this paper, sorry. Just a few more seconds. Alright, there we go. So, number 1. Again, we're looking for the GCF. We're going to find it, and then we're going to factor it out. So I have 6, 12, 9. Well, the number that I know goes into all of these numbers is 3. Okay, because 3 goes into 6, 12, and 9. And then I'm going to look at my variables, and I see they all have x. So what I'm going to do, 3x is my GCF. I'm going to write my GCF on the outside. And what we're doing is we're actually going to make this look like a distribution problem. So we're going to take this and make it look like a distribution problem. We're going to divide each of these terms by 3x. So 6 divided by 3 is 2. X cubed divided by x is x squared. 12 divided by 3 is 4. X squared divided by x is x. 9 divided by 3 is 3. X divided by x is 1. So we won't say 3 times 1, we'll just say 3. Okay? And so you'll notice inside my parentheses, I shouldn't have any GCFs left. When I think of a GCF inside my parentheses, it should just be 1. There shouldn't be anything with, all the terms shouldn't have variables. All the terms shouldn't have a number that multiplies evenly into it. Because if it does happen, we need to take that out and move it. And we'll look at that. Let's look at that in this next problem, okay? So, let's say I get to this next problem and I say, okay, these are both even, so I can take out 2. And this has x squared, so that's the biggest thing. So if I take out 2x squared, okay? So if I take out 2x squared, let's see what happens, what's left. We have 8 divided by 2, which is 4. X to the 5th divided by x squared, x to the 3rd. We have negative 12 divided by 2, negative 6. X squared divided by x squared is x. Now, notice in here that 4 and 6 are both even numbers. That means that there's a GCF between them. And that GCF is 2. So what I'm going to do, now that I noticed that, I'm going to factor that out. Okay? What happens when I factor something out on the inside is I move it out to the outside. Okay? Okay, so dividing on the inside means multiplying on the outside. So now outside I have 4x squared, and inside I have 2x cubed minus 3. Okay, and now in my inside, you'll notice that there are no common factors. Okay, there are no great GCFs left. Okay, let's try 5. When I look at, 3. When I look at number 3, okay, there is 5 and 20. And so the number that goes into both of those is 5. Okay, and notice this says d cubed, but this doesn't have a variable. So 5 is our GCF. I'm going to take 5 out, and what's left? D cubed plus 4. Okay. Alright, so again, you guys are going to do 4. Do 4. Look at the variables, look at the numbers, make sure you're taking out the GCF between both of those. And now number 5, which we'll do together. Okay, as you look at this, we have x squared plus 8x minus 9. When we're just taking out the GCF, we're going to look and say, okay, this is 1. The biggest number that fits into everything is just 1. Okay, and 9 doesn't have a variable, so it's not like there's a variable that can be taken out of everything. So if I factor out the GCF here, the GCF is just 1. It doesn't change the problem. So it's just x squared plus 8x minus 9. Okay, we'll talk about factoring trinomials like this towards the end of this chapter, being able to factor this. So we can factor this, but we will not be able to factor out a GCF before. Okay, so we'll have to talk about a new method later. Okay, I didn't want to leave that for you because I know that you might say, well, I didn't see how to do it, and now I'm totally confused. It's different than anything else. Okay, All right, so look at 4 and 6. Do that for me. Also remember that you have to do number 3 on the front of multiplying. Now at the end of this lesson, I hope that you're able to multiply polynomials by a monomial and find the GCF and divide or factor a polynomial. So we're really going into factoring a little bit. Okay, thanks. See ya.